everyone. Today, I'm going to discuss a new idea in physics. That means in our GC-LL examination, all the MCQs can be done in several methods. But there are two specific methods for every MCQ when we take. That means everything when you take, one thing you can think theoretically. Another one, we can use it in formula. But most of the students, what they are doing is, now for example, let's take Bernoulli's equation. They are directly applying P plus half rho V square plus rho GH. That is the only equation they know. A1, V1, they are applying like that. Similarly, they have memorized a set of equations. That means rotational motion means a set of equations. Torque is equivalent to I alpha, like that. But every equation can be think in so many ways. Some can be theoretical. Another one is calculation. But all the equations we can think in both ways. So I'm going to do an example for you. Let's see how to think a particular equation as an example. So I'm going to discuss the 2013 MCQ 44. So this question is related to Bernoulli's theorem. Okay. So now let's see. A cylindrical tank having a very large diameter contains two immiscible liquids of densities D1 and D2. D1 is greater than D2. That means D1 is at the bottom, D2 is at the top. The tank has a small hole closer to the bottom. The heights of the liquids at a certain instant are H1 and H2. What will be the speed V of the liquid ejecting out of the tank at the instant? Neglect the surface tension effects and assume that the liquids are non-viscous. Okay. So, let's see how to do this question. So normally we know we can do this question by applying Bernoulli's theorem. But we are studying hydrodynamics after studying hydrostatics, isn't it? So can't we relate hydrostatics and hydrodynamics together and get a new idea like that? Okay. Now they are asking in this question, what speed the liquid is what? The liquid is flowing through this pipe. Okay. So how can we think this question is? Now let's say we didn't put a hole. Okay. Now let's say there is nothing any hole. We didn't put a hole. Then we can write the pressure at this particular point, isn't it? Yes. If the liquid is still, that means if the liquid is not moving, the pressure at this particular point can be written as. Now let's say this is the atmospheric pressure part. Due to the height of the liquid column, we can write what this is density D2, this is density D1. Due to the height of the liquid column, there will be a pressure H rho GH D2G and H D1G. Therefore, pressure at this particular point is 5 plus H2 D2G plus H1 D1G. This is the pressure at this particular point. Okay. This is when the liquid is still. But the question is not like that. They have put a hole here. They have put a hole here and the liquid is what? It is moving with the velocity V. So when the liquid is moving, we can't tell the pressure like this. Only for static condition. The liquid is still only. That means the liquid is not flowing out only. We can write the pressure at this particular point as what? 5 plus H2 D2G plus H1 D1G. Okay. Now what is happening is, now we have put a hole here. Now what is going to happen is, now you see, when I put a hole here, this liquid is what? Exposed to the atmosphere. Therefore, what is the pressure at this particular point? 5. But before putting the hole, the pressure at this point is 5 plus H2 D2G plus H1 D1G. Now the pressure is 5. That means this much of energy has been going somewhere, isn't it? H2 D2G plus H1 D1G. Now we know in P plus half, in the Bernoulli's equation, P plus half from this to GH, we are talking pressure, kinetic energy per unit volume and potential energy per unit volume. Okay. But you know, in our universe and all, energy, we can't create energy. Energy cannot be created or energy cannot be destroyed. Always, energy is transformed from what? One particular form to another particular form. Therefore, this particular energy, H2 D2G plus H1 D1G, has been transformed to some other energy. So when we put the hole, this much amount of energy is not there. But there is a new energy coming. But it's that the liquid is beginning to flow through this. Therefore, what is we are getting what? We are getting a velocity. Velocity is related to what? In the Bernoulli's equation, kinetic energy per unit volume. That means this much amount of pressure energy has been decreased, and that is being converted into a kinetic energy per unit volume. Okay, therefore we can write the energy conversion directly. H2 D2G plus H1 D1G, that is equivalent to which liquid is flowing out, density D1 liquid, and is half into D1 into V square. Therefore, we can calculate this. 2G if I take common. 2 I am taking a G if I take common. H2 D2 plus H1 D1 divided by D1. This is what? This is the velocity. Therefore, we can write the expression for velocity. V is equal to square root of. Here what happens is D1 and D1 get cancelled. Therefore, we can get 2G into H1 plus H2 D2 over H2 D2 over D1. Okay. Now, this is what we are relating what after we are studying Bernoulli's equation. After studying hydrostatics, right? Therefore, during static condition, we are thinking first. After that, if the liquid is flowing, what amount of energy is what being lost, that is converted to a new energy after we step. Using energy conversion, we can approach this question. That means what we have studied related to that. Earlier method is what now we are studying Bernoulli's equation. No? We can apply Bernoulli's equation. So let's take, and this is our what? This is our tank. So we have two liquids. One is what? This liquid is what? This liquid is density D2. Okay? This is a liquid of density D2. Height is what? H2. This liquid is what? This liquid is density D1 liquid. Density D1 liquid. Height is H1. Now what is happening? From this particular hole, what? The liquid is what? The liquid is flowing out. Okay, so when we are applying the Bernoulli's equation, we will draw a streamline. Okay, so I am considering a streamline like this. Okay, so what is Bernoulli's equation is telling? Now in the streamline, okay, at any particular point, P plus half rho V squared plus rho GH is a constant. Okay, so therefore, after drawing the streamline, let us select the two particular points where I am going to apply what? Bernoulli's equation. But Bernoulli's equation, when we are applying, when the liquid is flowing like this, I draw dynamic case. Now let's say I am going to take I mark some points, for example, A point, B point, C point, D point. Okay, some points along this streamline. Okay. So there is not a compulsory that you apply A and B like that. Any two suitable particular points you can choose. Now our question is what? We have to calculate the velocity V. That means V is the unknown. That means other quantities should be known things. Now, for example, before applying the Bernoulli's equation, we have to choose one. A zero potential energy. It is like always not compulsory. You have to take the ground level as a zero potential energy level. Any level you can take. Okay. I am assigning my zero potential energy level. Therefore, first of all, I am going to apply Bernoulli's equation for the point A and D. Okay, at point D, what is the pressure? Since it is exposed to the atmosphere, the pressure is atmospheric pressure 5. Okay, you see, D1 density liquid is what flowing up. Therefore, the kinetic energy per unit volume is half into D1 into V square. Kinetic energy per unit volume is half into D1 into V square. Since it is lying in the zero potential energy, rho GH is what? Rho GH is equal to 0. That is what? That is a constant. Okay. Then I am applying what? Bernoulli's equation for the point A. Therefore, for the point A, it is exposed to the atmosphere. Therefore, atmospheric pressure 5 plus. So, what is the kinetic energy per unit volume? Now, the question they are told, this is a large tank. That means, if we are putting a small hole and a minute amount of liquid is coming down. Okay, when a minute amount of liquid is coming out from this spot level, there won't be a significant drop like that. Only a small amount. You can't see the water level going down. Therefore, we are taking what? The velocity of this large tank is what? 0. Therefore, no half rho V square. Half rho V square is 0. Then, you see, this is a zero potential energy level. From the zero potential energy level, this point A is at a height 1, H1 plus H2. Therefore, there is a rho GH that is potential energy per unit volume. Therefore, we can write down but D2GH2 plus D1GH1. This is the potential energy per unit volume. That is a constant. Okay. Then what we can do, we can equate these two. That means 5 plus half into D1 into V square is equivalent to 5 plus D2GH2 plus D1GH1. Then what? We can cancel off these two. Therefore, they are asking an expression for velocity V. We can calculate that. Therefore, half into D1 into V square is D2H2 plus D1H1 into G. Therefore, when you simplify for V, you will get the same answer. This one, that is square root of 2G into H1. H1 plus H2D2 divided by D1. Okay. Then you may wonder, now in this stream, I have considered so many points. Then why are you applying for A and B only? Why can't you consider some other points? B point you can consider, C point you can consider. The problem is now the velocity at the point B is unknown. Let's calculate the unknown velocity B. So if you consider D at some other particular points, B you have to consider definitely. Why at that particular point only velocity is unknown, that is a equation. Okay, but when you consider some other points like A, B, and C, A, why did I choose A? Because at the particular point A, I know the pressure. But for point B and point C, we don't know the pressure. Most of the students, they are doing the mistake is they are adding 5 plus H rho G at the pressure at the point B and pressure at the point C. Not like that. Why? Liquid is flowing. Hydrodynamics. Yeah, if the liquid is flowing, how can you write the pressure at the point B as 5 plus H rho G and the pressure at the point C is what? 5 plus H rho G. You can't write it. Therefore, pressure at the point B is unknown. TDPC. Already velocity is unknown. Therefore, if you put that, we can't find the answers. That is the reason for selecting what? The point A and the point C in this question. So you can see, now this is a particular question, 2013 MCQ 44. See, this question, normally we have applied Bernoulli's equation. That is one. But we are studying what hydrodynamics after hydrostatics. Okay, we can consider hydrostatic idea also. When the liquid is what? Still when the liquid is fluid. So any equation can be approached in so many ways. There can be some other ways also to think this equation. That's why these particular points you can't apply. Like using energy thing we have taken here, using static condition, using words. There may be so many methods. Therefore, any particular question, any particular question if you take, without analyzing the scheme, and we have this method for this question has to be done in this method. Then again and again doing in the same method, and don't memorize a question. Every question can be think in so many ways. I can't tell there is only 2 methods for this question. There can be several methods. You can relate some other area and think. Therefore, every question, that means they have given in the answer scheme one method. In your class, you have done one method. Some other new method, try to think. Try to relate with the other parameters. Then what happens? Your thinking skill will go up. Then you can think for what? Any equation. So any equation can be think in 2 ways. One way you can try the equation. If the equation is a little bit like equation, normally everyone tries to do it using equation. But think in a theoretical way also. Then if you think in a theoretical way, any equation, but you can find the answer. Okay. So thanks for watching. See you in the next video.